3.4, solving systems by inspection. Read and highlight. Let's go to work. What makes a system of linear equations have a single solution, no solution, or infinitely many solutions? One of the first representations we looked at for our systems was a graphical representation. What is true about the following systems of linear equations that have either infinite or no solution? So I'm looking at these two. What is true about those two? Well, there's an amazing thing. I like that they've decided to put these into slope-intercept form because we can see the slope right away. And that's the first thing that I want you to get about no solution and infinitely many solutions. In both of those cases, both lines will have the same slope. So what's obvious here is if they have different slopes, they will intersect at some point. If they have the same slope, they will either be parallel and have no solution. That was a lovely no solution. Have no solution, or they will be the exact same line right on top of itself and have infinitely many solutions. That's the biggest thing that we want you to get out here. Notice that the systems with no solutions and infinitely many had the same slope. In other words, those lines are parallel. If they're parallel, they have different y-intercepts. Then there's no solution to the system. If those parallel lines are in fact the exact same line, same slope and same y-intercept, then there are infinitely many solutions. The lines are sitting right on top of each other. Therefore, we could quickly determine whether the two lines have the same slope. We could know if it will have infinite or no solutions. If two equations are given in slope-intercept form, then we can readily see the slope and the y-intercept. Same slope, different intercept would mean no solution. Same slope, same intercept would mean infinitely solutions. But not all equations are given in slope-intercept form. Another common form of a linear equation is standard form. And remember, that's ax plus by equals c. Ax plus by equals c. Considering the following system of equations given in standard form, we can't readily see the slope or the y-intercept of either of those. Now, I'm going to call a quick little timeout, and I'm going to give you a refresher because I gave you two gifts. And those gifts were that the slope was negative a over b, and that the y-intercept was c over b. So in this case, remember this is a, b, and c. So this top line, our slope would be negative 2 over 1, and our y-intercept would be 5 over 1. Looking at the second line, my slope would be negative 4 over 2, which is a negative 2. So right away I could tell that they have the same slope. And then my y-intercept would be 10 over 2, which is 5. And that means they have the same y-intercept. So these two are, in fact, the same line. There's a little timeout, some other information that I had given you. But if you can remember, great. If you can't, well, you'll have to do it the hard way. So how can you find the slope? Well, we could solve each for y, but this method is called inspection. So we're looking for a quicker way. Let's get the second equation in slope-intercept form, see if we can find any patterns where the slope comes from. So as we simplify it and put it in slope-intercept form, notice that we got slope from dividing coefficients of the variables. Specifically, we started with the standard form, and we took negative a and divided by b. In other words, We simply took the ratio of the coefficients of each. If they're the same, then the lines of the slope, meaning it will be definitely either have no solution or infinitely many. Let's look at the original systems again. Notice that the ratio of coefficients, negative a over b, somebody just showed you that, right? For both equations is negative 2 over 1 and negative 4 over 2, which both equal negative 2. That means there is either no solution or infinitely many because they have the same slope. Now the y-intercept will tell us which one. But remember, if the two equations are exact same, they have infinitely many solutions. Otherwise, it'll have no solution. If we divided the second equation by 2 on both sides, we get the first equation. Since the two equations would be the same, any point on that line represented by the first equation would be on the line of the second. That means that we have infinitely many solutions and didn't have to do any work at all. Now consider the following system. How many solutions are there? Well, looking right away, I can notice that negative 3 over negative 2 is not the same as negative 2 over 3, which means they're not parallel. That tells us there is one solution. So in essence, we follow these steps if the equations are not in slope-intercept form. Make sure both equations are in standard form and check the ratio of the coefficients if they're equal. If they're not equal, there's a single solution we need to solve. If the ratios are equal, then we can check the equations to see if they're exactly the same. If they're the same, infinitely many solutions. If they cannot be the same, there are no solutions. Ladies and gentlemen, that is how you determine quickly by inspection if equations or the systems have one solution, no solution, or infinitely many solutions. Have a great day.